Have you ever wondered how energy is transferred between systems, how heat flows, work is done, and what the heck is entropy? Well, today, unravel the mystery of thermodynamics, a branch of physics that lays the foundation for understanding energy and its transformations. To start, imagine a system as a region of space or a quantity of matter chosen for study. Everything external to this system is what we call the surroundings. Within this system, there are properties. Some depend on the amount of material, like mass and volume, and are called extensive properties. Others, like temperature and pressure, are independent of the material amount and are known as intensive properties. At any given moment, the state of a system is defined by its properties. Any change in this state is what we call a process. Some processes occur at constant temperature, known as isothermal processes, and others occur without the exchange of heat, called adiabatic processes. Now let's dive into the laws of thermodynamics. The zeroth law states, if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. The first law, also known as the law of energy conservation, asserts that energy cannot be created or destroyed, it can only change forms. The second law dictates that heat naturally flows from hot to cold and introduces the concept of entropy, a measure of the disorder in a system. Lastly, the third law proposes that as a system approaches absolute zero, the entropy of the system approaches a minimum value. Energy is transferred in two main ways: heat and work. Heat is the transfer of energy due to temperature differences, while work is the transfer of energy due to a force acting over a distance. Different thermodynamic processes include isobaric, isochoric, isothermal, and adiabatic processes. The Carnot cycle, an idealized thermodynamic cycle, describes the maximum efficiency possible for a heat engine operating between two temperature reservoirs. Entropy, a measure of the disorder or randomness in a system, always increases in any energy exchange. Enthalpy is a measure of the total energy of a system, and Gibbs free energy measures the maximum reversible work that may be performed by a system at constant temperature and pressure. Phase transitions, like melting or vaporization, involve the exchange of heat without a change in temperature. And finally, when all the properties of a system remain constant over time, the system is said to be in thermodynamic equilibrium. Thermodynamics is a vast field with applications in physics, chemistry, engineering, biology, and environmental science. Its principles provide a foundation for understanding and analyzing energy systems and processes, making it an integral part of our understanding of the universe. So, the next time you boil water for tea or fuel your car, remember the principles of thermodynamics are at play, governing the transformation and transfer of energy.